This video we are going to talk about how to write a freestanding Rust binary. That means we don't have an operating system to run our program, um, and it's a freestanding binary. So that means it makes it possible to run Rust code on a bare metal without an underlying operating system. So what is bare metal? Uh, Bare machine refers to computer executing instructions directly on logic hardware without an intervening operating system. So basically some embedded systems. Today it is mostly applicable to embedded systems and firmware generally with time critical latency requirements. Okay, um, we can go back to this, and when we are writing a bare metal binary, basically we don't have operating system. This means we cannot use threads, files, heap memory, network, random numbers, standard output, or any other features. Okay, this means that we cannot use most of the Rust standard binary. So I'm going through this os.fill-opp.com. This is a very nice documentation for how to write an operating system in Rust, minimal operating system. Um, yeah, Today we are going to just see how to write a freestanding Rust binary. Okay, so where were we? Yeah, so this means we cannot use a standard library, Rust standard library. That means um, that means uh, we cannot use this files, heap memory, or anything like that. That means we have to use no std attribute, macro attribute. We will see that. Uh, this is a standard library like vec option. We should be able to use standard environment, standard macros. Yeah, we should be able to use primitives. Leave. And yeah, let's see. Let's go back. So that is for the standard library. But for example, we can still use iterators, the big thing, closure. That's also a huge thing. It's a modern language features, pattern matching. It's very nice thing in Rust. Option, okay, yeah, option we can use, and result, string formatting, yeah, and ownership system. So these things still we can use. These features make it possible to write a kernel in a very expressive and high level way without worrying about undefined behavior or memory safety. So that's the huge thing Rust is offering with respect to kernel programming. Uh, Coming back, um, I think we can get started. One thing is we would need to use Rust nightly, um, and as I said, we need to use no standard. So let's go back to VS Code and let's create a Rust binary. So cargo new hyphen hyphen pin. So this will create a folder for me. So open the folder in VS Code Rust OS, select folder. Yep, I got a default program. This is standard one, and I know that I don't want to use standard libraries, so I'm just hooking this attribute no std. Okay, that's the first thing. That's done. And let's go back to documentation. We have done that. Okay, now, yeah, we already got a compilation error since my VS Code is automatically compiling it, but let me build it for you. Println cannot find macro println. Yeah, no standard does not provide println. Okay, fine. We can just remove this. I don't want this. But will it solve the problem? This is kind of a compiler driven programming. It's a new thing coming up with Rust. The compiler will give you some error messages and warning to guide you to fix it. So language item required but not found EH personality. This is a little tougher for me, and panic handler function is required. Yeah. So let's go through what they are saying. Yeah, they also got the same thing. So panic handler attribute defines the function that compiler should invoke when a panic occurs. So that's a must thing. Standard library provides this, but non-standard we have to define. Okay, I'm okay to define that. I don't have any problem for defining that. Panic handler handler and f when panic underscore panic info. Yeah. And this is a diverging function. That means it won't return anything. So just looping it. So what it's saying is panic info. Okay. Let's build. Okay, should be percentage. It should be a uh, reference. Okay. Okay. Now again we are back to this. Not last time. Okay. EH personality thing. Okay. This EH personality language item. Language items are special functions and types that required internally by the compiler. For example, the copy trait is a language item. I see. Tells the compiler which types have copy semantics. Okay. So we see it as a special attribute that defines it as a language item. Okay. So each personality is a language item, marks a function that used for implementing stack unwinding. Okay, so if it requires stack unwinding, we need this EH personality item. By default, Rust uses unwinding to run the destructures of all live stack variables in case of a panic. And this causes that all our memory is freed and allows the parent thread to catch the panic and continue the execution. So disabling the unwinding, we don't want this unwinding. We just writing a minimal experimental learning noise, so we can just disable it. There are other use cases as well for which unwinding is undesirable, so Rust provides an option to abort on panic. So we can just write this abort on panic. We will add this thing in the cargo thermal file that will just disable this, I believe. Let's see. Okay, now it's coming another error requires start lang item. Another lang item start is required, but we have main, but it's not identifying main as a start item. Let's see what they are saying. Yeah, start attribute. So here the interesting thing is in a typical Rust binary that links the standard library. Yeah, if we are writing a normal Rust program, that means we are linking the Rust binary to a standard library, and execution starts in C runtime binary called CRT0. So in the backend of standard library, there is a C runtime. Um, Actually, it's execute a C program, and C runtime which sets up the environment for a C application. This includes a stack and placing the arguments in the right registers. The C runtime then invokes the entry point of the Rust runtime, then C runtime, then Rust runtime, which is marked by start language item. So there it comes the start language item. The C runtime actually calling the Rust runtime. Rust only has a very minimal runtime which take care of some small things such as setting up stack overflow guards and printing a backtrace on panic. Okay, the runs so the runtime then finally calls the main function. Okay, so that our Rust runtime is finally calling the main function. So we don't have our freestanding executable does not have access to a Rust runtime and CRT0. We don't have access to Rust runtime or C runtime. So we need to define our own entry point. If because we don't have a standard library, right? So we don't have getting these runtimes. So directly the binary will be looking for a start language item. If it needs to be a freestanding executable, it need to have a start language item. Why it is not there in our normal Rust program? This is the reason. Basically, the standard library, it has starts with a C runtime, CRT0, then it will call a Rust runtime and C runtime, then Rust runtime, which marked by, okay, this Rust runtime has this start language item. So it has this things, Rust runtime has this start language. That's the reason we are not seeing it. And this Rust runtime is basically calling our main function in normal or Rust program. But here we don't have this C runtime and Rust runtime, so our program should have this start language item because it's a non-standard freestanding executable. Okay, it's simple. Its things are again simple. We can just write. Okay, this is the core panic info that automatically came here. VS Code is helping me to write that. Where is my non-standard? Okay. Here I am again saying I don't have a main in this program. So no main. Okay, no main. Let's see. And no main. Then I don't need this main. Instead, okay, I have main. I'm deleting it. See what link exe. Oh, some other program. But since, as we discussed, we need to write a start with item. So how we will write that? It's a hash normal fn underscore start pub extend key, public function extend. It should be somewhere in outside, and it's a C like formatted one. And we are saying there is no diverging function. So what this means, so using no mangle attribute, we disable the name mangling to ensure that Rust compiler really output a function with name underscore start. So that means without the attribute, the compiler would generate a cryptic this kind of symbol to give every function a unique name. Okay, so no mangle means no name mangling. That means whatever we are giving here, it will be taken exactly as this name in our assembly code. Believe basically it's not rewriting the name, renaming it. This the attribute is required because we need to tell the name of the entry point of the function to the linker in the next step. Okay, so this the linker will be looking for underscore start, and we have it here. And pub extern means it will be a function not in this file, somewhere outside. When this program is getting executed, it will see this no mangle, so that means don't change the name of this function and look exactly same name underscore start in our anywhere in our linking program. Linker in the next step. We also have to mark the function as extern C to tell the compiler that it should be a C calling convention. So it's kind of convention like function name with parameters that I think the calling convention. Let's see what is that. Yeah, with subroutine, the C parameters. Yeah, our normal function. It kind of a C kind of a function. Um, the reason for naming function underscore start is that this is the default entry point name for most system. Okay, most of the system underscore start will be the default entry point. This exclamation as a return type means function is diverging, not allowed to ever return. It should not return. This is required because the entry point is not called by any function. Yeah, it should be called by us. No one should call it by invoke directly by the operating system or bootloader normally. Yeah, but in our case, I think it's our program. In our case, shutting down the machine could be a reasonable action since there is nothing left to do if every standing binary returns. For now, we fulfill the yeah for so instead of returning, the entry point should invoke a exit system call of the operating system. In our case, shutting down the machine could be a reasonable action since there is nothing left to do if a freestanding binary returns. For now, we fulfill the requirement by looping endlessly. Okay. Yeah, in normal program, when we do a shutdown, it is actually calling the exit system call. Yeah, having said that, let's see what happens if we compile this. Again, the same. Let's see what is the Rust version. Yeah, nightly Rusty Windows. Yeah, it should be. It's okay. Uh, error. Okay, I think it's taking the target as this. So let's I think I already changed the target as this. Let's see. I can give the target as this. Did I have any target? Minus target. Plus to Windows target. Windows target. Plus for Windows. Output I want. Potential target for targets. I think I changed the target to if I yeah, okay. Uh, a different linker error occurs. The entry point must be defined, which means okay, which means sometimes this things happens. I think this is what we are getting. Let's see entry points. Not be inferred. Oh yeah, 1221. Okay. Let's see. Use this one. Okay. Now it's got compiled. So yeah, there are some linking issues in Windows, so we can follow the document has this documented these issues here, so we can follow the same resolution steps. uh, I think that's all for us to compile. So cargo run, yeah, cargo run won't run because it's a bare metal one. Executed for what was target. Let's see what yeah, it's built for this, build created for target. um, yeah, we can do this here. uh, Yeah, we cannot run it with cargo run. This is a freestanding binary. Now our program should be buildable all the three platform with the cargo build. Okay. Yeah, that's true. It's building. So, but where's the binary? Right. There's the build defense creator. This. Let's remove this target and try again. Just build cargo build. Again problem. Again. 1561. So I think all the time I need to follow the steps. Yeah, start. So start entry point is not there. Let's plug it again. 121 221. Let's plug some system. Yep. Now it's got build. Yeah, rustOS.exe. Yeah. So this is what we got. Dot slash rust. Does it have anything we printing here? All right. Yeah. Uh, yeah, it's a start point, so it's not worth. Yeah, we cannot print anything. It's a loop. So Rust. Oh yes, if I execute this, curious what will happen. Debug. Yeah. Yes, Rust. Oh yes. Oh, not CD. Yeah, it's looping. Okay, Control C. So, oh, I cannot. Yeah, true. Yeah, it's basically an executable. We got executable, but another thing we have to try. So this is a Windows target. I don't want a Windows. I am going to run it on ARM processor. Then probably I need to change the target. So what I can do is, yeah, an example for such a bare metal environment is this. This is the target, uh, bare metal target, which describes an embedded ARM system. The details are not important. All that matters is that the target triple has no underlying operating system, which is indicated by the none in the target triple. This one. Okay. Here we are giving 86. My target, if you see, Rusty version verbose the x86 64 PC Windows, some Windows, some virtual machine, I think. But we want some non one. So let's do rust up target on this. I think I already added this, but I can try again. Copy, paste. The target is up to date. Okay, I already have it. So let's run cargo build for this. Yes, it's built, and you can see there is another folder debug, and see there is some executable here. So we built this starting freestanding binary for a ARM processor. I think that's all I meant to cover in this video. We will see. I can go through this next documentation steps. Um, See you later. Yeah, thank you.